next episode of Learning with Junaid. Today we are going to be talking about an interesting sorting algorithm. It's called as the shellSort. Let's first discuss what's a shellSort and let's discuss the formula, and then we will see the implementation. So what is a shellSort? A shellSort is basically nothing but an extension of an insertion sort which is applied to the sequence. So the idea behind a shellSort is to find a sequence of elements on which the sorting has to be applied. If you remember, in insertion sort, the sequence was applied to each of the elements one by one, but in the case of a shellSort, we applied to a specific sequence. So for us to find a sequence, it can be any sequence. You can have odd numbers, even numbers, you can apply the sequence to any kind of sequence that you want, but ideally there is something called as the Knuth algorithm. So we are going to follow applying the sequence based on the Knuth algorithm. What's a Knuth algorithm? For every value of h, this is going to be the algorithm 3 star h plus 1, and the inverse of this algorithm is h minus 1 divided by 3. So for 1,000 elements, if you have to find out what is the sequence, let's see the sequence for the first 1,000 elements. How do you apply? So for example, if I have 1,000 elements, I need to have some kind of a sequence of saying, okay, I will sort it for the first let's say 15 elements, and then for the next 40 elements, and for the next something 200 elements, for the next 400 elements, for the next 1000 something elements. So since this is greater than 1000 elements, so this will be our sequence. So we need to find out that sequence of how we are going to apply. So how is that going to work? So for every value of 1, we start off from 1 actually. So if this value will be 4, right now we are going to leave this blank. So next we take the value of 4, then what will be this value? This will be 13, and then the inverse of this is going to lead me to 4. Similarly, if I have a value of 13, and then if you apply this formula, your new value is 40, and then the inverse of this is 4. Sorry, this is 1. Similarly, when your value of h becomes 40, if you apply the formula, this is 121, and the inverse of this is 13, which is going to lead you back to whatever was this value. So similarly, you go ahead, apply now the value of 121. If you apply the formula, it's 364, and then we have 40. Similarly, when the value becomes 40 based on the formula, the value is 364, and then your new value is, if you apply the formula 3 star h plus 1, it is going to be 1093, I believe, and then you inverse it, you're going to get back this 121, and next take the new value of 1093. This would become 3280, and then 364. So you see, now you are going to apply the sequence for the first 1,000 elements. So obviously, this is greater than 1000, so you are going to discard this last row. So your new sequence, the not sequence, is 4, 13, 40, 121, 364. That's it, because 1093 is greater. So this is the Knuth sequence. So what basically you are trying to say is, you are going to apply the sorting, the shellSort, on every 4th element, every 3rd element, 40th element, 121th element, 364th element. So this is how it goes. So it comes from the right side. So every 364th element, you are going to apply the sequencing, or if you are going to apply the sorting. Once you are done with it, then you are going to go ahead and you are going to apply it for every 121th element. So you are going to go ahead and you are going to apply it 40th, 13th and 1, 4, then you are going to finally apply it to 1. This is your sequence. When it becomes 1, finally you will apply the insertion algorithm to all the elements in your sequence. So how does that look like? The first iteration, would apply. So example, now just break it down a little bit more. So let's take it for 200 elements to just get some more clarity. So for 200 elements, what should be my sequence? It should be 1, 4, 40, 1 to 1. Right, this should be my sequence. So let's see how we apply this sequence to 200 elements in an array, right? So if I have to find out a Knuth sequence for 200 elements array, so what is going to be my element? So I'm going to apply it to I'm going to apply 1, 4, 13 and 40. Every 40th element I have to start sorting, because after 48 what's element? It's 121. So I can't be sorting it based on every 121 element, because after 128th the next element is 364, right, which is far more greater than 200. So what we will do is we are going to apply the sequence of sorting for every 40th element. Once we are done with it, we are going to apply the sequence for every 13th element, then every 4th element, finally all elements for insertion sorting. So how does it look for every 48 elements? I'm going to start off with 0, then 40, then 80, then 120, then 160, then 200. So when I am going to do the same thing, I am going to continue. Next time it will happen for 141, 82, 121, 161. That's it, right? Yep, 161. And then I'm going to do the same thing again. I'm going to apply it, increment it to 2, 42, 82, 122, 162. I will go on doing it until I get to which point? 39, 79, 119, 159 and 199. So you see the sequence how it applies, like this. In this case, this is how the sequence would apply. I need to actually not take 200 into consideration. So this is how we are going to apply the sequence for every 0 to 40th element, 40th to 80th element, 80th to 120th, 128 to 160. Further go on applying it, and once you are done with this, you are going to decrement it based on this h minus 3, and then you are going to apply the sorting sequence based on 0 and then 13, 26, 39, 52, 65. It goes on until you get to 134. Next time you are going to increment it to 1, 14, 27, 40, 53, 66 until it goes to 195. And it goes on further until you get to which one? 12, 25, 38, 51, 64, 77 until 193. Once you're done with this, you're going to apply the sorting sequence for every fourth element, right, based on this sequencing that we are taking into consideration, based on this sequencing. So it will start from 0, 4, 8, 12, 16 all the way until it reaches 196. That's one sequence, and then you are going to apply it based on what? 1, 5, 9, 13, until it goes to 197. It goes on further until you get to a point of 3, 7, 11, 15, until it gets to 199. Finally, you will have 1 will be a all insertion elements. By this time you would have already sorted most of the elements. That's the beauty of ShellSort, because unlike insertion sort, here the sequencing or the sorting happens based on the subsequence. So now we have 3 components. We have to break down this implementation into 3. First is what we are going to do. Let's write down a pseudocode, and then we are going to go to the coding, and then we are going to break down. We have to first set your h is equal to 1. What is my h? This is my value, which is equal to 1. Okay, and repeat my steps, repeat the steps 3 until my h is greater than length of the array. As I told you, if you have 1000 elements, you are going to stop here, 364. This will be my sequence 1, 4, 13, 40, 121 and 364. After that, since the length of the array is greater than the 1000 elements, this is going to be my sequence. So that's what I'm going to do, and this is my first step. My first step is set my h is equal to 1. Second step is repeat steps 3 until my h is greater than length of the array. What is my step 3? Implement Knuth's algorithm for sequencing. What is an algorithm? Which is nothing but 3 star h plus 1, right? So implementing a Knuth's algorithm for sequencing, and how do you do that? You set your h is equal to 3 star h plus 1. That's a third step. So what you're saying, repeat step 3 until my h is greater than the length of the array. You understood why, and you implemented this. Fourth is what you have to do. Once you are doing that, apply the insertion sort to each subsequence. Let's see. Q subsequence. Apply to some sequence of S. Now that's my apply the intention, and then next is what do I have to do? I have to actually decrement. Once I'm done with one of the subsequencing, I'm done with 40, for example, I'm done with all the subsequencing of 40. I have to actually decrement and find the new value to subsequent. That is nothing but I have to take h is equal to h divided by 3. So that's my subsequencing. So I have to do h is equal to h minus 3. So then I have to apply this same thing, apply the insertion. Okay, so I have to apply these two things. There is one step here, I have to do the steps. Let's call it as 5, let's call it as 6, let's call it as 4. I have to do the steps 5 and 6 until what? My d is equal to, or my h is equal to 0. Until my h is equal to 0, I have to apply the insertion sort algorithm. H is equal to 0, because at 1, until 1, from the sequence 40, 30, 44, 1, until it becomes 0 h, I have to apply the insertion sort algorithm. I have to do this sequencing and then decrement it, then it will repeat it again and again. So that's the beauty of ShellSort algorithm. So let's see how we are going to implement this algorithm in the code. Okay, so let's go ahead and briefly implement this algorithm ShellSort. I have a shell program for the ShellSort right now. I'm going to use two tools. One is a visual representation. It will look like this, which has the contents of an array. The second one is our pseudo algorithm that we have written out here. This will actually help us implement the algorithm. The third thing is we are going to break down the ShellSort into 3 small pieces. The first piece is the Knuth sequence. How do you find the Knuth sequence? I have this algorithm. The second thing is to decrement the value of h every time we are done with one sorting of one of the subsequent. The third thing is to implement a insertion sort on the subsequencing. So these are 3 things that we have to remember. So first thing is set the value of h to 1, which is what we had. So I'm going to go ahead and set the value of h to 1, and I'm going to say while my h, that's what I had, right? While my h is less than length of array, which is nothing but less than a dot length. I can also take a dot length into a variable called n, because we will keep using it again and again. So let's say less than the value of h is equal to 3h. The Knuth sequence is what? 3 star h plus 1. If you just remember this, then you can easily implement a ShellSort algorithm. So I just broke it down into the sequence. So I will find out what is the sequence. Let me just print it out for the sake of clarity. This is h 4, 13, 40. So every 40th element, every 13th element, every 4th element we have to apply, and obviously I have to apply to the first element also. Don't forget the 1. Okay, now I'm not going to apply it for every 40th element because I have only 22 elements in this array, so there is no 40th element. So I'm going to go one level down and I'm going to apply for every 13th element. So let's find out what's the 13th element. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th, 28th is the element. So I'm going to go and mark 28. This is my element of interest right now. Okay, this is my element of interest for the subsequencing. All right, so that's my first piece of information. The second piece of information is what? I have to also do this at some point. At some point I have to also do this. That's the second piece of information. In between these two, I have to implement a insertion sort algorithm for a subsequence. How does a subsequent look like? So if you go to my pseudo code that we have written out, I have said that I have to do the steps 5 and 6 until my h is equal to 0 or it's greater than 0. What does it mean? If my sequence starts from 40, it has to end at 13, it has to then go to 4, it has to go to 1. So it can't be anything less than 1. Okay, so that's the logic behind implementing of this. If it becomes minus, then I have to come out. So what is the check for that? I have to say while my h is greater than 0, what do I have to do? Obviously I have to take this and I have to put it here, right? Because this is where I'm implementing my insertion sort algorithm. Perfect. You still with me? Okay, hopefully you are. Okay. Next thing what we will do is we will maintain 2 pointers. One is at the place where we started off the sequence. Int of I is equal to h, 13th element. I is less than n, which is nothing but the length of a array which I have, and then I plus plus. There are obviously going to be checks here that we have to do. The first thing that we will do is we will take the value of a of I and we will put it into an integer called as ai. Let's say a of I is what? 13th element, 28th. We are putting 28th here, right? This will become nothing but 28 initially, just for clarity. And then I'm also going to take my pointer I and I'm going to assign it to a variable called j. So let's go ahead and declare a variable called j here. Okay. Now I have to compare this 28, which is nothing but the 13th element, with the 0th element. That's how the sorting works. I have to take 28 and compare it with 23. If 28 is less than 23, then I have to swap the places. Perfect. So how do I get 0th element from this? I have j, which is nothing but 13th, and I have h, which is also 13. 13 minus 13 is 0. So I will say j minus h. That's 0, right? Okay. So if that value is greater than your a of I, that means if 0, this value is greater than this one, then obviously you have to swap the places. That's what we will do. While you see this, while a of j minus h is greater than zeroth element is greater than 30th element initially. Right? And then you also want to make sure that you have one more check here. Your j, whichever is that value, should always be greater than or equal to your h. We'll briefly understand why you are doing this when I debug the program, but this should be clear for you and this should be clear for you. And I'm going to remove these comments because this counter will now move one by one on the other side. Let's also add some println statements. So if this condition is true, is greater, then you have to swap the elements. So how do you swap the elements? Whatever was there at j minus h, that will go to whatever is there on j. That means whatever was there on j minus h, sorry, here j minus h is this one. This is nothing but j minus h. So whatever was there was j minus h. This is also h. This is also whatever there on j minus h. You are going to swap it if they are not equal, or if they are that is less than, or if j of minus h is greater than a of I. So that's very simple. Next is you have to make sure that your j minus h, the value equal to j. So what is j minus h? So you see it is j is 13, 13 minus 13 is equal to 0. So this is the value of j, that is the pointer that starts from the right of the index. And finally, once you are done with this, you are going to go ahead and you are going to take the value of a of I, and then you are going to put it into a of j. So that's pretty much it, I believe. You don't have to do nothing else except for like add a few statements for you to understand what is going on here one by one. Okay, I'm going to first add some statements here. Okay, system.out.println, add the value of j. The value of j is plus j. The value of I is I, and then the value at j, of j is, let's see what is the value of a at j. A of j and then I'm going to do something here. Let's say A of j plus the value at a of I is a of I. That's one printout statement, just for you to be able to understand what is going on. And then I will add a blank print statement just to be clear. And next thing is what we will do, we are just going to add one here. I copy, the block is executed, this block is executed, this block is executed only because a of j minus h is greater than a of I. So now what we will do, a of j minus n here, a of j minus h okay. So this will become block. This is only executed only because of this, and also the pointers of j of h is equal to greater than h, which you will understand now when I debug this program much better. Next is, once this happens, you have to swap. You have to actually swap the elements. I'm going to do something here, system.out.println. And next I'm going to swap the elements, right? Okay, set the value of a of j of h to, okay, set the value of j to be j minus h. Why? Because you have to now start off with, remember the sequence that we had. Once you had 14, then if your sequence was 13, then you went through everything, then next sequence will start with 14, and then it has to go through everything again. let's print out the value of j minus h here. Where j is equal to plus j and where h is equal to plus h. Okay, so now let's try to run the program and see how what we are going to see. I'm going to debug the program, debug pointer here, so as to see one by one what is happening. Let's go ahead and debug the program. Bingo. So you have here, you are going to implement the Knuth sequence. Okay, what's your h? H is 40. So you are going to actually do a check. If my 40 is less than the length, it is not. So the first time it's going to not even go into this loop, right? It's going to come here. Okay, now h is greater than 60. Now this time, you know what is the value, new value of h? 13. Yes. Okay, every 13th element. Let's go. So we have 28. As I said, you know, if you go here, this is my area of interest, the 13th element. I am going to print out one statement. The value of j is 13th. Yes. The value of I is 13th. Yes. The value of a of j is 28th. 13th element is 28, and the h and j are both standing at this place. Okay, that's good. Next thing, 13th, yeah, is greater than or equal to 13. Obviously, yes. A of j of minus h, that will be my j minus h. 23. Is 23 greater than a of I? Not really. So it's going to come here, and it's going to assign a of I is equal to a of j, which is good. That means keep the elements where they are, right? Next, come here. Still h is 13. I'm not done with 13 yet, so bam. Next time 13 yet. Okay, good. Okay, so now the value of I got incremented to 14. A of value of j is now 13th. The value of a of I is 13. What is 13th? If you see here, so you had this one was actually now 13, j of h 13. Yes, that's good. Yeah, so value of a of I is 13, which is because I got incremented. So we were at 13 here. Now the value got incremented to this one here, this one. This is my value of interest now, because we didn't swap anything, right? We didn't swap anything the next pass, right? So I'm saying 13. That's good. So I'm going to go ahead and say, what is j minus h? H is still 13. 13 is my sequence. J is 14. 14 minus h is 1. So now I'm going to compare this with the first element. This is 1. Yep, this block is being executed only because 13 is only because a of j of minus h 24 is greater than a of 13. So you see 24, is it greater than 13? Yes. So we have to now swap it. This comes here and this comes here. Swap the elements. You swap the elements. Now set the value of j to be 1, where j is equal to 14 and h is equal to 13. So if you implement the same thing again and again, what will happen? Now if I just go ahead and run everything, if you implement the whole thing again and again, you know, you see that finally your ShellSort algorithm would have sorted everything. So that's pretty much it, the most easiest implementation of a ShellSort algorithm. All you have to do is, oh, I forgot to tell you about this logic, right? J is greater than H. So let me just go ahead and tell you this logic again. There is a place where you know your J, what is J? 13th, what is H? 13th, okay, that's good. This is good. In this case, J is 15th. Is it greater than or equal to 13? Yes, it's going to come inside this. Logic is pretty simple. Every time you have this swapping going on here, you see the value of J minus H is being set to J. You want to make sure that you know your J, the value should always be greater than the sequence maximum limit. If it is 13, so it should always be greater, because in this case you would have made your J point to 3 or 4 in the array, the pointer. So you want to make sure that you know it's always greater than that your H. If not, what it will do is it will come out of this loop and it will start again here. The best way to understand that is just go ahead and debug, and I will show you the first time the swapping happens, what happens. So you have this no swapping. So swapping happened, why? Because 24 was greater than 13 in your array. Was 24 was somewhere 24, this one was greater than 13, so the swapping needs to happen, right? We understood that part. So every time that happens, what did I do? I took J minus H and I put it onto J. In this case, the new value of J is 1. So now what happens when the swapping happens? You see the value of J is 1. Is it greater than my sequence, that is not in 13? So it will obviously come out of this, that is swap the elements, assign the elements. So now you see my A of 13 got assigned at the first place. So wherever was there, 13 got assigned here, 24 went into its place. 24 went into its place, 13, 24 got swapped. So every time that swapping happens, you know, you are actually resetting the value of H. That's why you needed that check. If you don't have this check, you know, what will happen? You would have something like a array index out of bound. Okay, just run it at minus 12, right? So you reset it and then it will come out of this loop and then it will start again to the next element. So you go ahead, run it, bingo, the last point, ShellSort. So you have to just understand three things, break it down into three pieces. One of the piece is the Knuth sequence, get the Knuth sequence. Second piece is check until the sequence element, is it greater than 0? Until then you have to go ahead and you have to implement your insertion sort here, and then once you're done with it, swap the elements and then decrement or inverse your Knuth sequence to get back to the next least element of your Knuth sequence. If you started off with 13, the next it would be 14, next would be 4, and if you started off with 40, the next sequence would be at every 14th element, after that every 4th element, and every 1 element. So that's pretty much it. It might be slightly complicated to see, but you know, if you break it down into three pieces, Knuth sequence, decrementation and implementation of your insertion sort algorithm, then it all becomes very easier. I also have to talk to you about the efficiency of this algorithm compared to insertion sort. Let's see what it is. Repeated use of insertion sort within the shell sort would make it seem like it's a very longer algorithm to apply, right, for the entire sequence, but it's not the case. So for example, if you see from outside, it would look something like this, right? You know, you have, let's say you have an example of 200 elements, okay? And for 200 elements, how does shell sort work? You know, you have, let's say you have 40, that's my sequence. The sequence is 40, 13, and then 4 and then 1, right? So 40, so insertion sort, you know, it's 0 n square type. So 200 divided by 40 is 5 times, plus then you will be 13 divides 200 divides 13, how much, 15 times, right? Plus you will have about 4, which goes by 250 times, plus 1 is 200 times, right? So ideally, if it's a 0 n square insertion sort algorithm, so how would it work? If you go to your this one, let me just say baseline shift of 2. Right, I'm gonna do the same thing for this one and this one and this one. So if you add this total, how much would it be? Approximately about 53,925. So you would think, man, that's actually very worse than the insertion sort. Insertion sort would take about 40,000. You know, it's like insertion in what? N to the power of 2, that is 200 to the power of 2. Which is actually nothing but 40,000. It will look like, initially it will look like, man, this shell sort is actually worse than insertion sort, but that is actually not the case. It's not the case because after your first iteration, the subsequent sequence of an array are already sorted. In the sense, your actual number of comparisons needed there is actually very closer to n. That's the actual number of comparisons. It will look something like this. For example, you know, it will look something like this. Because you see, every time you are going through one list, it's actually already sorted out. So your approximate number of iterations to sort would be about 1595. Uh, 595. So you see, that makes a ShellSort algorithm actually with a better runtime. So it runs in ON ON and 1.5 times. ON 1.5 times compared to, like, you know, ON square of insertion sort algorithm. So for example, you know, it's for 200 elements, it would be approximately about, as I said, you know, n 1.5 is 2895, which is a lot better than 40,000. So that's how you're supposed to look at insertion sort algorithm. One more thing is the ShellSort algorithm is okay for lists that are not longer. The more longer your array list are, the more size it has, then it becomes worse. So you need to be careful in where you need to apply ShellSort algorithm. It's a complex algorithm compared to quicksort, merge sort, but still, you know, it would be an ideal algorithm if you know your list is less than maybe 5,000 elements and you want to apply it with less iterations. So it would be a better algorithm for a list that is smaller. I think pretty much it. If you have any questions, just don't forget to write some comments and ask me some questions if you have, and I will see you in the next class. Bye.